So morning we discussed about the inversions of four-bar mechanism. So one we saw with the crank rocker mechanism. So you can see the crank and rocker. Crank moves completely rotation, that is linked to complete rotation, whereas the four rocker one is just having the oscillation with C dash to C double dash. Drag link mechanism, you have seen the complete crank and the rocker is going to completely rotate, complete rotation with but with the different velocities. And in double crank mechanism, the links are equal. So links are equal and parallel. 1 and 3 are equal, and even 2 and 4 are equal and parallel. So this both will have the rotation motion. The double rocker mechanism same as the double crank or rocker, it is nothing but type of same mechanism. So then we discussed about the Grashof law, how the Grashof's law is going to be considered with sum of shortest link and the longest link should not be greater than the sum of other remaining two links, that we discussed. And then we discussed about the beam engine. So I told you beam engine nothing but 4-bar chain, 4-bar mechanism, and you are telling it is slider crank mechanism. No, so it is a 4-bar mechanism, but in this special case what can be done, the rotary motion can be converted into reciprocating motion. But you have seen that in slider crank only that rotary is converted to reciprocating or vice versa. But in beam engine you can see it is a 4-bar mechanism only, but rotary is converted to reciprocating. So this is a special mechanism that can be used. Okay, and we seen the double crank mechanism as coupling rod of locomotive, that we saw. And what straight line mechanism? I told you, no, this is a straight line mechanism. So this is under 4-bar mechanism only, but you can see the straight line can be observed. Okay, what's a straight line mechanism? So I'll just show you some example video based on this. So you can just see here. I'll just share that screen also. Okay, can you see? Just tell me. So 4-bar, what straight line? Okay, can you see the screen? Okay, just share it once again. Okay, see here, you can see what is happening. The motion, if the motion link is made to oscillate here, but still that point, if you take that trace of that point, it will be straight line. You can see there that red color line at the center. You can see the it is made to move in a straight line. You can just see the crank is made to rotate little bit, and you can see the path followed, it is a straight line. So this type of mechanism can be what straight line mechanism. Okay, next I will show you one more you can see here. I'll present that video. Okay, see the same. So you can see the red color path, straight line. Okay, so this type of mechanism will be a straight line mechanism. Okay, so I'll continue with the next part. Next we come to the slider crank mechanism. So till now what we saw from morning, it is a 4-bar chain or a 4-bar mechanism where always a type of rotary motion is considered to convert only rotary, but only in special case we have seen beam engine also converting from rotary to reciprocate. But in the slider crank mechanism you can see the rotary motion is converted to reciprocating or vice versa. Okay, so in kinematic chain having having 4 links, so 1 sliding pair and 3 turning pairs. Okay, so we discussed on many classes the working of slider crank mechanism. So this link number 2 is known as a crank. Okay, so this is crank, and it will give the rotary motion from O to A as the radius. It is going to trace a path of circle from O2 as center and O to A as the radius always there will be rotation of this crank. Okay, and then link 3 can be considered as the connecting rod that will combine the rotary and the reciprocating motion, and is called the connecting rod. And link 4 is the having the reciprocating motion, and it is known as the slider. Okay, so slider is going to also this reciprocate in this direction, in this line, axis line, which is shown here. Okay, and link 1 is the frame that will be fixed here at the bottom. Okay, so this mechanism is used to convert the rotary motion into reciprocating motion, or reciprocating motion to rotary motion. So best example is your in your engine, piston and crank and connecting rod. Okay, so crank is this one, crank is going to rotate, and connecting rod is going to push the piston. So piston is nothing but here slider. Okay, so that will be going to reciprocate. So this is the slider crank mechanism. Okay, again in this slider crank mechanism also there may be different inversions possible. Okay, so inversions of slider crank chain can be seen. So in the first case you can see if the crank is fixed. Okay, so if the link 2 in this figure you can see the crank is fixed, what will happen? It will give different type of motion. So 3 is going to oscillate, the slider is going to see from there, and link 1 is not fixed, so it will go oscillate in that direction. If second case connecting rod, if it is fixed, what will happen? 3 is fixed there, and you get different type of motion. And last you can see that when the slider is fixed, automatically you will get the slider as fixed, and you will get a different type of motion. So in different inversions are possible apart from the normal consideration. So this is with the link 1 fixed, normal consideration, and if 2 and 3 and 4 are fixed separately, so you will be getting this other inversion. So totally there are 4 inversions possible. Okay, so one is normal when link 1 is fixed, when one link 2 is fixed, and when third is fixed, and when fourth is fixed. Okay, and others is going to move, have the motion. So let us see the basic example of a slider crank mechanism shown in figure. So link 1 and 2, you can see that link 2 and 3 here, and 3 and 4, and all are having the turning pairs, whereas link 4 and 1, they are forming the sliding pair. Okay, so that is the slider, piston connecting part, that becomes the slider. So let us see the different inversions of single slider crank chain. So first one we see the inversion pendulum pump or bull engine mechanism. So in this mechanism the inversion is obtained by fixing the cylinder or the link 4. So this is the fourth inversion, type of fourth inversion, when the slider is fixed. Okay, so you can see the slider itself is fixed, and you can see link 4, this is cylinder, this slider itself is fixed, and in the inversion the cylinder is, or link 4 is fixed. Okay, so when the crank rotates, the connecting rod oscillates about a pin pivoted to the fixed link 4, and at A, and the piston attached to the piston rod, that is link 1, is going to reciprocate. Okay, so the duplex pump which is used to supply feed water to boilers have 2 pistons attached to the link 1 as shown in the figure. Okay, so you might have seen the in the villages there are pump which are used, okay, for drawing the take the water from the ground level. Okay, so they are using the different hand pumps. Okay, when you oscillate, the same type of example is shown in this pendulum pump. So when you push the lever there, automatically the reciprocating motion will be seen, and automatically water will come out from that. Okay, so that type of mechanism can be seen in the fourth inversion type of mechanism with the pendulum pump. Then you can see the oscillating cylinder engine. So in this case the arrangement of oscillating cylinder engine mechanism, you can see the figure. So used to convert the reciprocating motion into rotary. So reciprocating is converted to rotary. So in this mechanism the link 3 is fixed. Okay, so that is forming a turning pair. You can see the figure. This is the third link made at the base part here. So here the link 3 forms the turning pair, and that is made fixed here, and the link 3 corresponds to the connecting rod of the reciprocating steam engine. And when the crank 2, that is this crank, is rotated here, and the piston attached to this reciprocate in this direction, and the cylinder link 4 oscillates about the pin pivoted at the fixed link A. So this is the fixed link A. So it is going to reciprocate. So this is regarding the oscillating cylinder engine. Okay. So next we will see the rotary internal combustion engine, that is our GNOME engine. Okay. So sometimes back rotary internal combustion engines were used in aviation, but nowadays gas turbines are used in this place. Okay, so it consists of different number of cylinders. So in this figure we have you can see 7 cylinders in one plane, and all revolves about the fixed center D. Okay, while the crank is fixed. Okay, you can see the center, the crank is fixed here, and that is others will going to reciprocate in their manner in the cylinder. Okay, so it may be 3 cylinder engine or a 4 cylinder or a 7 cylinder, any type of cylinder. It is a type of GNOME engine. Okay, so when the connecting rod rotates, the piston reciprocates inside the cylinder, forming the link 1. Okay, so this is the type of rotary internal combustion engine. So next we'll see crank and slotted lever. So before that, I'll just show you the animations on this. Just stop this. I'll show you the animation so that you'll understand. So single slider, we'll see the examples of normal piston.
Nothing rockers. With this you will get with us, and therefore this will be called. These are firing. There is in a reading line like this tank mechanism.
Can you see the screen video?
We can consider either the crank or the slider as the input link. Rotating motion into rotary motion, as in case of IC engine, or the rotary motion into reciprocating motion, as in the case of a reciprocating pump or compressor. In its physical form, it can be represented like this. Link AB shown over here.
So this is normal slider crank mechanism. When the rotary motion is there, automatically there will be reciprocating motion.
The slider moves back and forth. The link that
but if you try to change a little bit of
is called
inversion with the different
the two
links,
extreme positions
so you can see what type of inversions are possible.
Are called TDC, top dead center.
So here this one normal
BDC
type of normal consideration when you can see bottom dead center and the top dead center
in internal combustion
so
engines.
This is example of slider crank mechanism.
Pumps and compressors.
So this is example you can see. So rotary motion at the bottom and reciprocating motion you can see at the piston side.
A cylinder.
And it moves from top dead center to the bottom dead center.
Several slider cranks arranged in line like this.
Now you can see several
inline engine.
Arrangement of this, all the slider crank can be attached in one.
They can
and you can see
how
the rotary engine is going to work. So you can center, you can see the rotary motion of that. You can see that is completely linked to is fixed here, and other will have the motion automatically. So other cylinder is going to oscillate.
Let us follow this link to see a radial engine in action.
So you can see the animation.
So this is how a radial engine looks in 3D. Of course, typically it would have more cylinders than just 3. And let's set it in motion.
See there?
The cylinders are firing in a cyclic order, and they are all driving a single common crankshaft. Slider crank.
Okay. So in the same way, I'll show you one more.
A slide is fixed. We'll talk about that in a moment. The version of slider crank looks like this.
You can see this video. So oscillating cylinder engine. At the back side of this you can see that mechanism. From front side it is not visible. You will see at the rear side of this. So there you can see. Then just now we see about the radial engine, groom engine also I will show you. So this is the you can see that simultaneously you can see the motion observed there. So same way different number of cylinders also possible. So you can see number of cylinders connected there. This is a normal arrangement that already you know, you have seen this piston cylinder arrangement. So piston is going to reciprocate, you can see there, and automatically the crank is going to rotate there. So this already you know these things, so just you can see the animation there. So with the different applications they can perform different type of for different application different type of mechanism can be built. So you can see one more so in this case you can see double type of two sliders are attached at the same point. So you can see the rotary motion, one input is only one rotation, where it is operated with two sliders there simultaneously. So like this different for different application you can create your own slider. You can see two paths there. So according to that application you can change the type of mechanism. Okay, so for a different application you can use the different types of mechanisms. Okay, so next we'll go with another type of inversion. So next, crank and slotted lever quick return mechanism. Okay, so in quick return mechanism what will happen, this is observed in shaping machine or slotted machines and all, and also in rotary internal combustion engines. So the return stroke is faster than the for the input stroke there. So return stroke is always faster, that will come fast. Okay, so in this mechanism you can see that I will show you the figure there. So this is the figure. You have to draw this figure in exam because that will give you the clear picture how it is going to oscillate. So you can see from the figure, this is the link 1 from here, and this is the slide of crank which is there from this point B to C. So crank is linked to here, and from this is connected to the fixed part of link 3 from here, and is connected to one more rod and connected to the ram at last. Okay, so when this is the crank is going to rotate in this direction, what will happen? The B point will move from B1 to B2, and also this P is going to oscillate. This entire link is going to oscillate from P1 to P2. So it will be like P1 to P2, and automatically with this link connected to the RAM, this that will connected to R1 to R2. So this is the line of stroke. So this is the cutting stroke. This will be the return stroke. So return stroke will be faster because time required for the return stroke will be faster. You can see the beta and the angle of alpha. So alpha you can see that is shorter, whereas the beta angle is larger. Okay, so from this the time of cutting stroke beta is you can see divided by that time of cutting stroke divided by time of return stroke will be beta by alpha. So we'll be getting the return stroke faster in this case. Okay, so these are the different notation given there. So link 3 correspond to the connecting rod. Driving crank CB revolves with uniform angular speed about the fixed center C, and the sliding block attached to the crank pin at B slides along the slotted bar AP, and thus causing AP to oscillate. Then the short link PR transmits the motion from AP and to that is RAM, so that will move from R1 to R2. So this is the cutting stroke, or line of stroke on this R1 to R2. So at the extreme position AP1 and AP2, you can see the time of cutting stroke divided by time of return stroke will be beta by alpha. So beta and alpha is nothing but 360 minus beta. So this is nothing but 360 minus beta. This is the complete 360 degree, and or it will be 360 degree minus alpha divided by alpha. Okay. So anyway, the return stroke will be faster. That's why it is known as the quick return mechanism. Okay. So if you take the equation now corresponding to this, so that will be equal to R1 R2, and that is nothing but R1 R2 is nothing but P1 to P2, same thing. Okay, so that is nothing but equal to 2 P1Q. That is you can see this is point P1 to P2, and this is taken it as Q here. Okay, at the center. So from here to it becomes that is equal to P1 to P1Q. So this is half of that. Okay, and that is equal to nothing but 2AP1 sine angle of P1AQ by trigonometry equation. So using this equation, finally we will be getting that one as this one is nothing but CB1 by AC. So we are getting the equation as 2AP into CB by AC. Okay, so that because CB1 is equal to nothing but CB only. So you get this type of equation. Same way we have one more quick return mechanism, that is Whitworth quick return mechanism. This is also used in the shaping machine. Okay, so in this case what will happen, the fixed link is nothing but link 2 here, that is the crank itself is fixed here. So from this is going to oscillate in two different direction. So one is the inner part here at the point D and another at this point C. Okay, so when this entire link is connected at this motion, this is going to oscillate, entire link is going to oscillate over here, and this will push the RAM. So again RAM R is again the line of stroke will be from R1 to R2. Okay, this is the cutting stroke, and automatically you can see here the return stroke again will be faster. We can see the angle is again for beta is smaller than the angle alpha. So this is going to rotate in this direction, in clockwise direction. So this is that is driving the crank link 3, and this is the slider link 4. Okay, so this will be pushed by the connecting rod, and the RAM is going to oscillate in this direction. Okay, so this is again used in shaping machine. In all shaping machine you can use, when you use the shaping machine manually, that time you can see the inside arrangement, how the quick return mechanism is being placed inside that. Okay, so here link 2 is made it fixed here as in the figure shown, and link 2 corresponds to the crank of the steam reciprocating steam engine, and crank 3 CA rotates at a uniform angular speed, and whereas slider, that is link 4 attached to the crank pin at A, slides along the slotted bar PA, okay, that which is oscillated at a pivoted point D, and connecting rod PR carries the ram at R, to which a cutting tool is fixed, okay, and the motion of the tool is constrained along the line RD produced, that is along a line passing through D and perpendicular to CD, okay. So in the same way, the time of cutting stroke by the time of return stroke will be nothing but 360 degree minus beta divided by beta, same as the crank and slaughter lever, okay. So if the question, if it is asked to give explain a quick return mechanism, you can write this also, crank and slotted lever also, or you can study Whitworth quick return mechanism, any one is okay, okay. So any one you can study from both of these things, don't have to study both of this. I am explaining both because quick return mechanism both are used, crank and slotted lever and as well as Whitworth. So any one from this two you can use, okay. So let us see the animation based on this.
We have seen what a slide we are going to in its.
So you can see here how the changing can be done for the quick return mechanism.
Right now we are also seeing will be
so
used
this is the
link A. This
normal link
of slider crank,
normal slider
like
crank. So
this.
you can see how
link
the inversion
is fixed.
is possible.
So this is link AB fixed.
So AB is made here fixed
will be
points
used as the input. So this link BC will be used as the input and will be moving this.
So you can see there
Right
that will be made to oscillate
some traces
from B to C.
Points.
You can see
we'll
there.
talk about that
So you can see the motion in the
so this
path
inversion
of BC
can be made a little more useful by adding couple of extra links. Here they are.
So mainly this will be the link,
So
but just additional is done to
AC
reciprocating that tool.
like this.
Okay.
Add
So
one
you can
extra
see the
link
motion which is
here,
possible there.
and at the end of it we will attach a tool which is constrained to reciprocate along this line. So as our input link BC rotates, the tool
So you can see there
reciprocates
motion
back
how
and
it is there. The slider there,
Now
that
let us
point
see
C will form
its
the entire
extreme
circle there.
positions. So
Okay,
the
and
tool
the inner bottom there you
in
can
the
see one more
rightmost
circle created
extreme
from the point A,
when our input link BC
and you
is
can see
over
the
here,
in this case the return
then
stroke will
we
be
will
faster.
retract it back. So
Tool is going from here, and the lower bottom you can see automatically
here.
you can see there
BC is in this
forward
position,
stroke having
and then
the
again
angle
it will
more
move
angle,
forward.
return stroke having shorter in the figure shown
So
there.
it
So
retracts
you can see there.
and
So here
moves
it retracts again, it
forward.
comes at the forward
But
position.
if you notice the angle through which our input link is turning when moving forward and when retracting the tool back,
So you can see the red color
these two
indicated there.
angles
This will be
are
the return
not
stroke,
equal.
only this part, red color. And the
and
green
therefore
part here at
the
that
tool
will be
will
the
take
forward
more
stroke.
time
So
to
the
go
time required for
forward,
the return stroke will be
and
less.
in a
That's why it is
lesser,
known as quick
shorter
return
time,
mechanism,
it will be retracted back.
used in shaping
Such
machine.
mechanism is called a quick return. Over time brought back a ratio of the tool
So you can see the quick
divided
return
by
ratio
the
will be
angle
forward
turned
stroke
by the
and
crank
crank angle by the
for
return
the
stroke
return
crank
stroke
angle.
of the tool. Transfer angles, it is quick mechanism. As the next,
So we'll see one other type
we
of
get a
inversion
link
then.
which only oscillates. The resulting mechanism looks like this in its bare essential. So our input is slider. As the slider moves along a circular path, it drags
So
the
now you can
guide
see.
with it. So this guide only oscillates back and forth. Next, we are going to path like inversion
See here,
number 2.
A to B there point it is having the rotary motion, and that is entirely connected from the C to this point, and when it is rotating, the crank is going to have the motion from B to A. Automatically the tool position will move from to and fro motion. Again here also quick return ratio followed by the return stroke.
Slider slides the slotted
so forward stroke by the return stroke.
We use uniform in action. So this
you can
is
see the animation there.
Return stroke, and red, which is a larger angle, is
red color will show you the forward stroke.
Instead of
then green will be the return stroke. Return stroke will be faster.
A slot, we have used a cylindrical lever, and instead of the slider,
the return stroke
we
is
have
faster.
A sleeve which slides on it. But essentially the mechanism or the characteristic of the mechanism remains the same. Let us now go to here. Here we have to oscillate. This is used for some of the practical. Number 3.
Okay, so you saw some basic concept regarding different inversions. Okay, so let us see one last one.
The basic slider crank mechanism, where we have a fixed link, and on one side it has a crank, and on the other there is a number version. Looks.
So you can see the pendulum hand pump which is there. You can see the hand pump which is used in the bore water when in the villages. You just oscillate this crank automatically the lever, and you can draw the water from the ground. The same thing is shown here.
It has slider look in a little more detailed. So this link
so you can see this is going to oscillate in this manner.
And indeed we get A and B as fully rotating pins.
So you can see that AC that will be in a straight line oscillating from this
cylinder. The body of
so water can be retracted from this. You can see this animation.
With which it can be moved. And then we have this mechanism.
So if you oscillate here, automatically there will be, you can see the reciprocating motion there.
Is used in hand pumps, and that is one of the applications of inversion number 4.
So fourth inversion type of thing you can see here in the hand mechanism. Okay, so these are the different inversions there for the slider crank mechanism. Okay, so try to understand because many inversions are possible and different applications are there. So at least one inversion from each type, okay, that you can study. So any one if inversion is there, you can write that, and also any specific things are there, you can also go with quick return mechanism. Any one you can study from there. Okay, so I have given you a number of inversions which are possible, so you can go with any one inversion for the exam. Okay, so in either you can study Whitworth quick return, or you can go for crank and slotted lever for quick return mechanism. Okay, so these are the different inversions possible for single slider crank mechanism. Next we have after that we have double slider crank mechanism also, that we'll see in the next class. Okay, so we'll not continue to double slider now. So let us stop here.